Good evening, everyone. So today we got rudely interrupted by the bell, and there was also some confusion. So I'm going to go over this example problem again, and hopefully it'll be a little more clear this time. So, integration by parts. We talked about how substitution reverses the chain rule. Integration by parts reverses the product rule. So these are the two biggies that we dealt with in 251 last semester. And the format here is the antiderivative of u dv equals product uv minus the antiderivative of v du. And notice I've switched exclusively to Leibnizian notation here. I think that's going to be a better fit. Rather than using u primed and v primed, I think this will come out better, and you'll see why in just a minute. So as we talked about today, we try to choose a du that is simpler than u and choose a v that is simpler than dv. It's important to note that sometimes if you make a bad choice, it'll just create a mess, and that's okay. Cross it out, start over, start on a fresh sheet of paper. That's all right. So, in our example today, we had the antiderivative of x squared times e to the x dx, and using this format, we at first tried using letting u equal x squared and letting v equal e to the x. And we'll get dv here in just a second. We'll look at it in those terms. I think we're going to be all right. So I'm going to make my little sidebar over here, kind of a big one. And so we had let u equal x squared, then du dx will equal 2x. Then multiplying both sides by dx times dx times dx, I get du equals 2x dx. And there's one thing that I need right up here is my du. And then we said let v equal e to the x, dv, derivative of v with respect to x, equals e to the x, also special function, and dv, which we also need over here, then again multiplying both sides of the equation by dx, dv is equal to e to the x dx. And that's what I saw over here. So this whole thing, now we can use this whole thing right here as my dv. So now I've got u dv. Life's good. And we're ready to integrate by parts. So then this will equal uv, oh, not there, come on, uv minus the integral of v, the antiderivative of v du. So now we have the antiderivative of x squared e to the x dx equals, my u was x squared, my v was e to the x minus the antiderivative of v e to the x du 2x dx. Okay, so far so good. And stop this if you need to. Study it for a moment. That's fine. So now we have the antiderivative of x squared e to the x dx equal x squared e to the x minus, notice we have a 2 in here, which we can bring out, but not 2x. The x is still a variable, so we've got to maintain that. So we can say minus 2 times the antiderivative of e to the x dx. Okay, notice that this is still a product. This is still a product here. So we're going to, so at this point, a lot of you can solve this one directly. We do have another integral here. But I do want to show you the technique of integrating by parts a second time, since we still have a product here. And as we said earlier, integration by parts reverses the product rule. So let's think about this and do it a second time. Okay, I'm going to make another sidebar. It's okay. And, and as I said, I know this is fairly simple. I'm probably going to drive Derek crazy. But let's just do it a second time. It's okay. Stick with black, I guess. Let u equal x this time. That makes sense. And so my u can be here. And so then du dx equals 1. And again, multiplying both sides. Maybe I can slide that over. Get a little more room out of it. Multiplying both sides by dx, I get du, which I need, equals 1 dx, or just dx. So I've got a du, which I will need. I have a u, which I need. And then I need my v. And once again, we're going to let v equal e to the x. Then derivative of v with respect to x equals e to the x dx. Same technique. Oh, I'm sorry. I jumped ahead. Skipping a step. Sorry. And so then multiplying by dx both sides, I get dv equals e to the x dx. And again, I'm getting dv to fill in this spot right here. I got du to fill in this spot right here. I have my v and I have my u. So we can do this separately. I think right now I'm just going to leave the rest of this off for now and do this part over here. And I wish I had a totally different color. I haven't used that purple yet, so let's do that, okay? So we're going to say the integral, and again, I'm just doing this part right here, the integral of e to the x, maybe I should write that backwards, the other way. The integral of x, e to the x, dx, okay? I can say equals u times v. Now again, let me see, what color did I use up there? Blue. Okay, so we're saying u times v. But in this case, my dv, all of this, was e to the x dx. So I have dv. That's good. That's good. So remember, I need u dv equals uv. Maybe I should just remind myself of that. uv minus the antiderivative of v du. Okay, so I have then, I got to be careful here so we don't goof anything up. So then I have u dv equals, I'm going to stick with purple, equals, and I need a uv x v e to the x minus the antiderivative of v e to the x du dx. Okay, and let's check that. So we have uv minus antiderivative of v du. Okay, so this is uv and v du. So u was x, v was e to the x, antiderivative of v e to the x du is dx. Okay, we're good. 1 dx or just dx. We're good. Okay, now I see the method here because this allows me to just take the antiderivative there, which we can get directly. Okay, let's put it all together. Bring everything down. We've got to bring this down. We've got to bring this down. And we've got to bring that down. So I have now the antiderivative of the first original problem, x squared e to the x dx equals x squared e to the x minus 2 times, I'm going to put all this, you know I love these guys, x, I'm bringing this in, x e to the x minus the antiderivative of e to the x dx. So keep going, we're almost done, this is going to be good. The antiderivative of x squared e to the x dx equals x squared e to the x minus 2 times x e to the x minus, okay, antiderivative of e to the x dx is simply e to the x. So then when it's all said and done, we can say the antiderivative of x squared e to the x dx equals x squared e to the x minus 2x e to the x. We got to distribute. Don't forget that. Plus 2 e to the x. And Jeremy, don't worry, plus c. I won't forget about you. I probably should have put a plus c up here since I already did it. Okay, there we go. And I know that seems like a lot, but I want you to be exposed to the process of this. And that's important. And it won't hurt us if we take our time. We'll get to go a little faster later. But wait, there's more. Let's see, who's the doubter in the room? I'll pick on Alex. Alex Howard is probably saying, hey, Mr. Jennings, I don't believe that that's true. There's no way that the antiderivative of x squared e to the x dx equals x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Okay, you may be right, doubting Alex, but let's check it by, you guessed it, taking the derivative with respect to x of each one of these elements and seeing what happens. I need one more. Okay, so lots of products here, and I see this minus. We're going to be a little bit careful there, but not too bad. So we're going to use the product rule a lot. So we can take the first, x squared, times the derivative of the second, e to the x, plus the derivative of the first, 2x, times the second, e to the x, minus, and we got a big minus here, so I'm going to put that together. And we'll distribute the minus later. The first, 2 to the x, times the derivative of the second, e to the x, plus the derivative of the first, 2 times times the second, e to the x, plus the first, 2 times the derivative of the second, plus the derivative of the first, 0 times the second, e to the x. Okay, let's keep going. X squared e to the x plus 2x e to the x minus 2x e to the x. That's nice. Now, here's where we distribute. Right there. Don't forget that. Oh my gosh, Alex, people forget that one, and it is a sad, sad day. Minus 2 e to the x plus 2 e to the x plus 0. We can even put that one in if we want to. Okay, so right off the bat, I see a couple of nice things here. Here's a minus 2 e to the x. Here's a plus 2 e to the x. Those guys are going to subtract out. Oh, look, there's more. If you order right now, you can get rid of these guys too. And what are we left with, Alex Howard? Check it out. X squared e to the x. Looks a lot like this. So that checks. What a happy day. Well, I hope that this clarifies everything, because today that did not go all that smoothly. So that's about all I have. We're at 17 minutes, 20 seconds, and that's probably enough. I hope this is helpful, and have a good evening. Go Calculus.